Hello, this is a presentation created by Ben Cromer and Carson Hunter. We seek to prove that nuclear energy may not be the best option for humanity in the near future. The nuclear energy dilemma, a cause for alarm. One of the biggest debates in the nuclear energy field is whether or not the plants are safe enough for commercial use. One of the biggest parts of this debate is the events that took place in Fukushima. The plants had a near meltdown and caused a lot of radiation to escape into the atmosphere and damage the nearby area's environment. We're going to look at what caused the event and what this means for nuclear power in the future. Because this doesn't just affect Japan, it expands outwards and affects the entire nuclear energy field and how humanity will be evaluating its worth in society as a power producer. The cause of the event was a 9.2 magnitude earthquake off the coast of Japan, generating a 15-meter tsunami that struck the plants of Fukushima. This amount of seawater was very damaging to the plant's reactors. They were simply not built to withstand this magnitude of a wave or of an earthquake, and the fail-safes failed, to be honest. All three Daiichi reactors lost supply to cooling and backup power from diesel generators. The cores melted in the first few days and generated large amounts of radiation and fallout. That radiation and fallout is still there today, and in fact, we're going to look at the cause a little bit more in depth on this video on the New York Times.
The 9.0 magnitude Japanese earthquake has had many frightening after effects, but perhaps none more so than what unfolded at the Fukushima No. 1 nuclear plant, where explosions and radiation leaks across the plant's 6 reactors have resulted in evacuations and emergency containment procedures. The Fukushima 1 plant houses boiling water reactors that were built in the 1970s. Dr. Ronald Ballinger, a professor of nuclear science and engineering at MIT, explained to Time over Skype how the reactors work and how the earthquake tested their design.
So in a boiling water reactor, water comes in the vessel and steam is produced directly in the reactor vessel, and the steam goes out and runs a turbine. Think of a coffee cup full of water. You stick an electric heater down into the water and it heats the water up. In the case of the boiling water reactor, the heater is the fuel rod and it produces steam.
On Friday, March 11th, when the massive earthquake rocked the nuclear plant, there were many safety measures in place, but the chain of events and their magnitude challenged all the backup plans.
They had an earthquake, a big one, and those reactors automatically shut down. Then they had the tsunami. Now, when the reactor shut down, the power grid was lost, and so they had diesel generators on site, but the tsunami washed away everything. And so they were in a situation where they couldn't run pumps, they couldn't get water into the vessel to keep the fuel cool, and they damaged and locally melted some of the fuel.
In nuclear reactors, the main danger is that without enough cooling, the radioactive fuel can become so hot that it melts through the reactor walls, releasing high amounts of radiation into the environment. Boiled water reactors, like the ones at the Fukushima plant, have their fuel surrounded by multiple layers of containment to prevent this kind of release.
The fuel rods themselves are the initial barrier for release. Then there's the pressure vessel itself, the primary coolant system. Then there's a containment vessel.
To cool down the fuel, engineers injected seawater mixed with boric acid into each containment vessel. But the intense heat converted the water to steam, and a reaction with the coating on the fuel rods created an excess of volatile hydrogen gas.
So, they had to vent the hydrogen somewhere. Otherwise, the pressure would go too high and they wouldn't be able to get water into the reactor.
In 2 of the reactors, No. 1 and No. 3, the hydrogen gas was vented into the building surrounding the containment vessel.
There's a facade kind of superstructure, which is the outer part of the building. The top part of that, the hydrogen was vented up into that area and it pooled apparently, and that's where the explosion occurred, and that's when you saw all of the debris and stuff like that.
These explosions released very little radiation because the buildings are not part of the reactor containment. But in reactor No. 2, some hydrogen gas ignited within the containment vessel itself, causing a small crack and releasing moderate amounts of radioactive material into the atmosphere. More radiation was also released when there was a fire in reactor number 4, which was shut down at the time of the earthquake. The flames were in a separate tank called the spent fuel pool, where radioactive fuel is stored when not in use.
If damage occurs in the spent fuel pool, then some of those fission products can get out. If it's a gas, it'll be airborne.
Scientists the world over have their eyes on the reactors at Fukushima, and each of them might offer a different prediction on the risks as engineers work to keep the reactors cool. For now, the world can only watch and wait to see if modern engineering can overcome a catastrophe so far beyond what anyone thought possible.